Alright, hello and welcome back to Algebra. So let's take a look at our topic for today. We are going to be talking about how to solve quadratic equations in class today. So let's start off by taking a look at a very basic quadratic equation. So here's an example. X squared plus 3x minus 4 is one possible way in which a quadratic equation can be written. Well, in order to simplify this and in order to find out what possible values x can take, we've discussed the factorization theorem and factorization theory in the past. We try and figure out what factors allow you to solve for x. However, what I want to teach you guys today is to how we can actually make the entire process automatic, and you don't even have to worry about figuring out the factors. All you need to know is how we can break down this equation into a form that can be solved using the quadratic formula. So let's begin. I can rewrite this equation in the following form. I know x squared has a coefficient of 1 associated with it, so I'm representing that coefficient of 1 right here. I know x has a coefficient of 3 associated with it, so I'm clarifying and simplifying it here. And then lastly, I know the constant associated in our equation is -4, so it comes down just the way it was. Now let's take a look at this quadratic formula. This states that the value of x can be determined by plugging values into this equation and solving it in a designated form. So what exactly is A, B, and C? Well, I wrote them down right here for us to see. So A is nothing more than the coefficient associated with x squared. So in this case, the coefficient associated with the x squared is 1. So that's the value that A takes. B simply is the coefficient associated with x. And in this case, it is 3, so B takes on the value of 3. And then last but not least, C is the constant in the quadratic equation. It's always considered in the positive form, hence C takes on the value -4. And now we have everything that we need in order to solve this quadratic equation. Alright, so the next step in the process is to simply plug in the values A, B, and C into our formula. So that's what I am doing right here. B, it starts off with -b plus minus square root of b squared minus 4ac over 2a. So now that we have numerical values for these constants, I'm simply going to plug them in. So -3 is the value for b, because it's a -b, plus minus square root of b squared, so 3 squared, minus 4 times 1, which is our value for a, and then of course c is -4, so that goes in as well. Any questions? Alright, you guys all seem fairly happy, so we are making progress. Alright, so the denominator of this formula has simply a 2a. We know a has the value 1, so we plug that in, and we get 2 times 1, or simply 2 in the denominator. Alright, so now we have the whole equation solved. If we look over here, all I'm doing is simply forming a little bit of cleanup underneath the square root sign. So when I simplify these two terms, you should end up with 25 under the square root sign, and this fraction simplifies to be -3 plus minus square root of 25 over 2. The plus minus right here means that there are going to be two possible solutions for our values of x. And that's to be expected, right? Because when we did the factorization, you also ended up with two different roots or two different values for the variable x, and that's what this formula provides us with as well. So the two ways in which this fraction could solve is the following. you could have negative 3 plus 5 over 2, or negative 3 negative 5 over 2. And based on the two different fractional values, x can take on either the value of positive 1 or the value of negative 4. So those are our two possible roots for this quadratic equation. How can we be absolutely sure that we did not make any errors? Well, let's do a small quick check just to make sure our roots are correct. So what I'm doing right here is to plug in the values for the roots that I got into my original equation and see if the left-hand side is equal to the right-hand side. So in other words, once you plug in the value of x into your original equation, if you don't end up with a 0 on the left-hand side, then we've done some kind of a calculation error. Alright, so let's plug in the value 1, which gives us 1 squared plus 3 times 1 minus 4. That definitely simplifies to a 0. Therefore, we know the first root that we calculated is correct. How? Well, it solved the equation and balanced the left-hand side and the right-hand side, so we are in the clear. Let's do the exact same thing using the second possible root for x. So the second possible root for x is negative 4, and all I'm doing in the very last line is plugging in the value negative 4 into my original left-hand side of the equation. So I get negative 4 squared plus 3 times negative 4 minus 4, which simplifies to positive 16 minus 12 minus 4. So again, I end up with a perfect balance between the left-hand side and the right-hand side, which tells me that my second root that I found for this equation is also correct. You see how this, using the quadratic formula, completely automates the process. You don't have to worry about figuring out what factors would simplify this equation, but instead all you have to do is pick out the coefficients associated with x squared, x, and our constant itself, and then plug them in to our formula to get the resultant roots. Did anyone have any questions? Alright, great. See you next time.